going to begin now, section 2.2 video. Section 2.2 video, part 1. And what I want to do first in this particular section is, just by way of introduction, I want to go over a few things with you. So I'm basically just for the first few minutes, I just want you to just watch the things that's on the video. I will give you a few notes in a minute that I need you to take down, and so I'll tell you what you need to write and what you don't need to write. So if I don't tell you to write it down, you don't necessarily, I wouldn't worry with writing it down. Now, if you want to, that's your option. You feel free to do so. But I'm going to use these next few notes just by way of introduction. The equation, we have looked at two different kinds of equations so far in this course. We have looked at linear equations, and we've also looked at quadratic equations. But both of those equations, a linear equation, x was to the first power, a quadratic equation, x was to the second power. But in those equations that we looked at, both of those equations only contained a single letter, a single variable. All the linear equations we solved contained the letter x. Now, I don't have to use the letter x, but that's the letter that we use. But now, the x could occur multiple times. It could occur here, and then over on the other side of the equal sign. But it was only one single letter x. Even in the quadratic equations, it was only one letter. Now, it may have had an x squared and an x in it, but that's still only one letter. So up until this moment, we have not looked at an equation that had two letters in it, two different letters. For instance, like an x and a y, or an m and a t, or an s and a y, or an n, whatever. So we haven't looked at equations with two variables. Now, when you first look at it, you don't think it's that big a deal. For instance, if you look at these two equations right here, the one on the left is an equation. More specifically, it's a linear equation, because remember, linear meant your variables to the first power. This is a linear equation, one variable. This is an equation with two letters. And so your first thought when you first look at that, you think, well, throwing in that extra letter in that problem is really not that big a deal. Well, let's look at that and let's see how big a deal it is. If you look at the one on the left right here, the one on the left says what plus 2 equals 5. Now, if you think about that, of course, that's easy to solve. Just subtract 2 from both sides. But what plus 2 is 5, obviously the answer to that is 3. Now, not only is that the answer to that problem, that is the only answer to that problem. What plus 2 is 3. But look at this one right here. This one on the right says, what plus what else gives me 5? So in other words, in this problem right here, we're talking about give me a pair of numbers. Now, I'm going to talk about this in just a few minutes, talk about ordered pairs, and I'm going to give you a quick crash course on ordered pairs in just a few minutes. But before I get to that, this right here says, give me a pair of numbers that adds together to give you 5. Well, let's examine that a little bit. So, if I let x be 1 and let y be 4, is 1 plus 4 equal to 5? Certainly it is. But if you add 2 plus 3, you get 5. If you add 3 plus 2, you get 5. If you add 5 plus 0, you get 5. Now let's move to some of the answers that are not so obvious. 4.7 and 0.3. Does those two pair of numbers add together to give you 5? Yes. 1.4 and 3.6. Do these two numbers add together to give you 5? Yes. 6, -1. 7, negative 2, 8, negative 3, 9, negative 4, 10, negative 5. And you say, well, Mr. Hunter, wait a minute, you could go on forever doing that. And you're exactly right, I could. So all I got to do is keep this pattern going. 9, negative 4, 10, negative 5, 11, negative 6. And I could go on my entire lifetime and never give you all the pairs of numbers that add together to give you 5. So ask you the question now. Does it make a big difference when you go from an equation that has one letter to an equation that has 2 letters? Absolutely. It makes a huge difference. Because you then go from an equation that typically only has one solution to a problem that has millions of answers. And by the way, whenever you look at this pair of numbers, 8 comma negative 3, this is your x, this is your y. Remember, in ordered pairs, and I'm going to review over this with you in just a minute. Remember, in ordered pairs, we typically call the first number x, the second number y. So this is a pair of numbers that add together to give you 5. So though you're looking at 2 numbers, it's not 2 answers. This one point, this one ordered pair is one answer. So this is one answer. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 answers to that problem up there, up at the very top. And we hadn't been talking about this problem but a couple of minutes. And I could keep going on and on and on forever. So all I'm wanting you to see right now is when you throw in an extra letter into a problem, it drastically changes your number of solutions. And I'll come back to that in just a few minutes. I'm going to give you a couple of notes on that in just a minute. But before I do that, let me go back and review back over something with you that you may or may not remember. So you copy as much or as little of this down as you need to. Just use your own discretion. You pause the video if you feel like you need to copy any of this. What I want to do with you right quick is I want to review with you. Let me say again, you pause the video and copy whatever you need to if you feel like you need to. I want to review with you over graphing. Now, when I'm talking about graphing, I'm not talking about graphing what we call, in algebra, we typically do 2 different types of graphing. We graph what's called a one-dimensional graph. That's where you graph just on a single number line. We'll do that as well in this course. Then we graph also what's called 2-dimensional graphing. Now, whenever you go to a 2-dimensional graph, the graph looks something like, and you'll probably remember it once I show it to you. The graph looks something like this right here. And again, pause the video if you need to copy this, if you want to copy it. All right, so we've got, this is a 2-dimensional graph because it uses 2 number lines. Now, we call this number line right here the x-axis. We call this number line right here the y-axis. Now, there's nothing magic about x and y. Sometimes in physics and in calculus, we may call this S and T. Sometimes it's called R and theta. So sometimes the names of these axes, they're not always X and Y. But typically in an algebra course, it is. We just because those are the equations that we usually use those are the letters that we usually use in our equations. So this is a number line and this is a number line. We give them names to distinguish the difference between the two. So this is what we call the x-axis. This one's called the y-axis. And so since it's a number line, the further you go to the right, the more positive you get. The further you go to the left, the more negative you get. The further you go up, the more positive you get. The further you go down, the more negative you get. Now this graph, the point at where the 2 axes intersect, if you remember, is what we call the origin. It was called the origin because everything we do, we typically start with our pencil at the origin. The x-axis and y-axis splits your graph up into 4 main sections referred to as quadrants. And they are numbered counterclockwise. We start right here, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That's how these quadrants are numbered. All right, now the numbering system is universal. It never changes. So quadrant 1 is always up here, quadrant 2, etc. Now what I want to do is I want to remind you of how to plot a point in this system. So if I ask you to plot the point 2, 3. If you remember in algebra, this is what we refer to as an ordered pair. It's called an ordered pair because the order in which you write it makes a difference. You know, I tell my intermediate student class when I'm teaching it this way, if you're going to a house in downtown Laurel and you stop at house 23 or house 32, that's two different houses, two different locations. Well, 2, 3 is not the same place as 3, 2. That's why it's called ordered pair. Ordering matters. Obviously, it's called pair because there's two numbers here. This first number, the mathematical name for it is called the abscissa. A-B-S-C-I-S-S-A. You don't have to know that, but that's the first name. The first number is probably the most common name, is most teachers refer to it, as do I, refer to it as what's called the x-coordinate. So the first number tells you how far to move left or right. The second number, the mathematical name, is called the ordinate, O-R-D-I-N-A-T-E. More common name for it is the y-coordinate. It's the number, it tells you how far to go up or down. So the first number tells you how far to move left or right. Second number tells you how far to move up or down. And then after you've made both of those moves, the point at where you're located is where that point's located. So for instance, if I said, where is the point 2, 3 located? You would go 2 to the right, and then 3, 1, 2, 3, straight up. So right there would be the point 2, 3. It would be to the right 2, 1, 2, and up 1, 2, 3. So that point right there is located in which quadrant? Quadrant 1. Now, what if it was negative 2, 3? Negative 2, 3 would be 2 to the left and up 3. And that's where that point would be. Now, what if it was negative 2, negative 3? Be to the left 2 and then down 3. What if it was positive 2, negative 3? Then it'd be 2 to the right and down 3. So if the first number is positive, you move to the right. If the first number is negative, you move to the left. If the first number is 0, you don't move left or right. For instance, if this was 0, 3, you would move none left or right up 3. So 0, 3 is right here. But if it were 3, 0, the first number moves you left or right. So 3, 0 would be here and then stay right there. So the first number tells you how many spaces to move left or right. The second number tells you how far to move up or down. As a matter of fact, we can make a general comment about the points that's located anywhere in the what we call the XY plane. All right, think about where a point can be located. It can be in quadrant 1, it can be in quadrant 2, it can be in quadrant 3, and it can be in quadrant 4. And you say, well, those are the only options. No. If it's on the x-axis, it's not in a quadrant. So it could be on the x-axis. It could also be on the y-axis. So if a point is not on the x or y-axis, it's not in a quadrant. So here's how we can generalize this. Every point that's located in quadrant 1, the first number's positive and the second number's positive because you move to the right and then up. Now, what if I'm in quadrant 2? How do you get in quadrant 2? You go to the left and then up. So every point that's located in quadrant 2, the first number will be negative, the second number will be positive. Now, if you're located in quadrant 3, you move to the left and then down. So all points in quadrant 3 has a first number negative, second number negative. If you're in quadrant 4, the first number is positive, but the second number is always negative. That's if you're located in quadrant 4. Now, I said a while ago, if you're on the x-axis, you're not in a quadrant. However, if you're on the x-axis, all of those ordered pairs have something in common, and it's this. If you're located on the x-axis, the second number is 0. So like 5, 0, negative 3, 0, 8, 0, negative 1, 0. Anything, 0 stays on the x-axis. Why? Because the second number moves you up or down. If the second number is 0, you don't move off of the x-axis. So 3, 0 would be 3 to the right, stay on the x-axis. Negative 5, 0 would be 5 to the left, stay on the x-axis. Now, on the other side of that coin, if you're on the y-axis, this one, the first number is 0. 0, 1, 0, 8, 0, negative 3. All of those are on the y-axis. Now, why is that the case? Because if the first number is 0, that moves you left or right. If the first number is 0, you never move left or right. That means you have to stay on top of the y-axis. So if I ask you where is 0, 5, that would be none left or right, but up 5. Or 0, negative 3. That would be none left or right, down 3. Still on the y-axis. And we give those points a special name. You'll hear me refer to this a little bit later on. Any point that is located on the x-axis, we give it the special name, the x-intercept. The word intercept and the word intersect carries with it the same meaning. So if you're on the x-axis, that is an x-intercept. And all points on the x-axis has a second number of 0, or has a y value. X, y, has a y value of 0. And every point that's on the y-axis, which is called the y-intercept, has a first number 0, or x is 0 in your ordered pair. And then, of course, if you're at the origin, you're at the point ordered pair 0, 0. Okay, I've already mentioned to you that we're going to be talking about equations with two variables. Now, what was the big difference between an equation with one variable and an equation with two variables? First, when you go from an equation with one variable to an equation with two variables, your answer is written as a pair of numbers. You go from one equation with one letter with equation with two letters, your answer is a pair of numbers. So this is one answer, this is one answer, this is one answer. So your answer is not a single number, it's a pair of numbers. But not only is it a pair of numbers, there's billions of them. Remember when we did this list earlier? We said that list could go on and on and on. So there's an infinite number of answers to these problems. So I will start out in the very next video picking up on this with a very, very important note that you will need to write down. So this concludes section 2.2 part 1 video.